A 50 kilogram girl wearing high heel shoes balances on a single heel. The heel is circular with a diameter 1 centimeter. What is the pressure exerted by the heel on the horizontal floor? Acceleration due to gravity is 9.8 Newton per kilogram. Now, so what do we have? We have the value of mass of the girl, and we have the value of diameter of the heel, and we have the value of gravity. Now we have to find what is the pressure. So pressure is equals to force by area. Now what is the value of force? So we know force is equals to mass into acceleration. So here mass is 50 kilogram and acceleration due to gravity is 9.8. So it is 50 into 9.8. What about area? So as it is circular, the area of circle is pi r square. So pi 3.14 into r square. And please remember, mass you have to take it in kilogram, and diameter you have to take it in meters. Okay, you have to take in SI system. 3.14 into 0.005. That is what is the. So here it is given diameter. So you have to take the value of radius. So diameter 1 by 2, that is 0.5 centimeter. So that gives you 0.005 meter. So you are doing pi r square, and the answer what you get is the value of pressure. Torricelli's barometer is used mercury. Pascal duplicated it using French wine of density 984 kg per meter cube. Determine the height of the wine column for normal atmospheric pressure 1.013 into 10 power 5 Newton per meter square. Take gravity equals to 9.8 meter per second square. So please see, here we have the value of density of the wine, and we have the normal atmospheric pressure. The value of pressure is also given, that is 1.013 into 10 power 5 Newton per meter square, and we have the value of gravity. And we should find the value of height of the wine column. So this height of the wine column should be such that the pressure of the case should be equal to the atmospheric pressure. So that is what is the question. And we have already seen the formula for pressure at a certain height for a given liquid, and it is H rho g. Okay, so we have already seen this. It is dependent only on the height of the liquid column, it is dependent on the density of the liquid column, and gravity, and it is not dependent upon the shape of the vessel and the area of the bottom. So we have seen that. So from using this formula, we are getting the answer. H is equals to P by rho g. Value of pressure is given. You have to take the value of pressure in Newton per meter square. Please remember that. And you have to take density in kilogram per meter cube, and gravity 9.8 meter per second square. So this is the value of height for which the atmospheric pressure will be equal to this pressure. A vertical offshore structure is built to withstand a maximum stress of 10 power 9 Pascal. Is the structure suitable for putting up on top of an oil well in ocean? Take the depth of the ocean to be roughly 3 kilometers, and density of the water is 10 power 3 kilogram per meter cube. Ignore ocean currents. Let us see the answer. So the actual pressure that the structure which can withstand is 10 power 9 Pascal. And here the case given is the height, that is the depth is 3 kilometer, and the density of the liquid is 10 kilogram per meter cube. Now if this is the case, then this structure suitable for withstanding the pressure? So that is what is being asked. So for that we have to find the value of pressure. So pressure, we know the value of pressure is H into rho into G, and the value of height is, or the depth is 3 kilometer. We have written in meters, 3 into 10 power 3 meter. Value of density is 10 cube kilogram per meter cube, and G is 9.8 meter per second square. So the value of pressure is 2.94 into 10 power 7 Pascal. So what does it mean? This actual structure can withstand a pressure of 10 power 9 Pascal, but the pressure because of this case is only 2.94 into 10 power 7 Pascal. So the structure is suitable for putting on the top of oil well. So the answer is yes, it is suitable. A hydraulic automobile lift is designed to lift cars with a maximum mass of 3000 kg. The area of cross section of the piston carrying load is 425 cm square. What maximum pressure would the smaller piston have to bear? Take gravity equals to 9.8 meter per second square. So a hydraulic automobile is designed to lift cars with maximum mass of 3000 kg, and the area of cross section of the load that is the piston carrying load, that is which has maximum area is 425 centimeters square. And now we have to find the pressure in smaller piston. So if you see, if A is the area of cross section of the bigger piston and F is the force applied on it, that is the because of mass, then the pressure, what is the pressure on this piston, that is the larger piston? We know the mass is 3000 kilogram and force is mass into acceleration. So 3000 into 9.8, and value of area is 425 centimeter square, and we have to write it in meter square. So 425 into 10 power minus 4 meter square. Then the pressure on the larger piston which has maximum area is F by A. So it is 3000 into 9.8 by 425 into 10 power minus 4, and the answer is 6.92 into 10 power 5 Newton per meter square. Now this pressure is transmitted unchanged through the liquid of the hydraulic to the piston of the smaller cross section. Okay, so the smaller piston will also bear the same pressure of 6.92 into 10 power 5 Pascal. A U-tube contains water and spirit separated by mercury. The mercury columns in the two arms are in level with 10 cm of water in one arm and 12.5 cm of spirit in the other. Calculate the relative density of the spirit. So please see. So the mercury columns in the two arms are in level. So the mercury columns, yes, you can see they are in level. Okay, with the 10 centimeter of water in one arm. So in one arm we have 10 centimeter of water, and in another arm we have 12.5 centimeter of spirit. Okay, so here it is spirit and here it is water. Calculate the relative density of the spirit. So we have to calculate the relative density of spirit. So relative density, what is the meaning of relative density? The density of spirit by the density of water. So that is what is relative density. Okay, we will see the answer now. So yes, as the mercury levels in A and B are the same horizontal line, so in the same level, the pressure at point A due to the water and the pressure at point B due to the spirit will be equal. Okay, so as these mercury levels are equal in these two cases, the pressure due to water and the pressure due to spirit at A and B respectively are equal. Okay, so now we can use the formula H rho G, because we know what is the pressure due to liquid when it is filled with certain height. We know what is the value of the pressure. It is H rho G. So if you want to find for water, you have to use H rho G. For spirit also, yes, it is H rho G, but you have to use the respective heights and densities of water and spirit. Now H rho G of water equals to H rho G of spirit. I can cancel G and G. So rho S by rho W. What is that rho S by rho W? Density of spirit by density of water. And if this is the case, then this is called as relative density of spirit. Okay, what is the relative density of spirit? It is density of spirit by density of water. So that is equals to height of water column by height of spirit. So what is the answer? It is 10 centimeter by 12.5 centimeter. So the answer is 0.8. So this is the value of relative density of spirit, and please see it has no units. Okay, because it is density of something by density of water, so the units are same, so they cancel each other.